Well, welcome to our first midterm review. So just a reminder, our midterm is this Thursday. There will be 3 videos posted, one Monday night, Tuesday night, and Wednesday night. Each video will contain 5 questions similar to ones that would be found on the midterm. And most likely, I'm going to pick the ones that I think as a whole we struggle with the most. So as you can see, we've got 5 questions written out here. 1, 2, 3, 4, 5. Basically, the idea here is that you would pause the video, work out all 5 questions on your own in your notebook. Then when you've completed all 5, you can kind of scroll to the next page and you'll see my answers. Okay, so the next page will just be a glimpse of my answers. If you continue on, say you got question 1 wrong, then continue with the video and I've worked out question 1 step by step, explaining everything in detail. Same for 2, 3, 4, and 5. If you've gotten to the second part there and you see you've nailed every answer, by all means, you don't have to listen to my explanations of them. But of course, if there's one you missed or 2 or 3 you missed, make sure you go back and listen to the explanations. If, for example, complex fractions, question 1 here is something you struggle with, don't forget you can go back and review any video that we've done this year. They're all on your Moodle. All right, so at this point, best of luck. Pause it, work them all out, and I look forward to seeing what you've got. All right, well, just like promised, here are the answers to the 5 questions that we've picked for our midterm review. Number 1, negative 5x over x plus 1. The biggest mistake I've seen in the past on quizzes and tests is that people have these backwards for some reason. So if you fall into that bear trap, you definitely need to keep going and watch how to actually solve this problem. Number 2, make sure you've rationalized your answers. 3, we just saw in the spiral last week. 4 is a little bit of a review, and 5 we've been chugging with quite a while. If those fractions kind of tripped you up a little bit, again, make sure you continue on now and watch how the solutions are worked out. So question 1 was our complex fraction. So I already have taken the liberty of factoring everything, which I'm sure you've done correctly yourself there. Okay, now, our biggest issue comes in canceling. Do you see where I drew my blue line here? You can only simplify the top fraction and only the bottom fraction. You can't simplify them together. Okay, so let me slow down again. Just looking at the top fraction, can anything simplify? Well, of course, x plus 2 and 2 plus x are the exact same thing. So I'm going to rewrite my main fraction on top as 2 minus x all over x plus 1. Okay, now can you simplify only the bottom fraction? Sure, the x plus 7's cancel. So my bottom fraction is x minus 2 over 5x. Okay, now it's just a nice, easy, complex fraction. You just look for the least common denominator. And I would say that I need an x plus 1 and a 5x. So I'm going to multiply that x plus 1 and 5x to the numerator of each, and then ask myself if I can cancel anything. On the top fraction, mainly above the division line there, the x plus 1's cancel, so I get 2 minus x and 5x. In this bottom fraction only, the 5x's cancel, so I get x minus 2 and x plus 1. Now you'll notice that these are different by a negative, and what do we mean by that? Well, 2 is positive, now 2 is negative. X is negative, x is positive. So they cancel to that lovely negative 1. So I get a final answer of negative 5x over x plus 1. Our second problem is called factor by grouping. So again, if this seemed very foreign to you, go back through Moodle and find the factor by grouping page and rewatch that video. Anyways, here's how we solve this. Our goal is to find 3 GCFs. So the first thing I do is I box in the first 2 terms, and I kind of box in or bracket in the second 2 terms, and I'm looking for a GCF here. So we'll start with the first 2. It looks like I can pull out a 4 and an x squared. So that's what I'm going to take out. That is my first GCF. Now here's what you do. You divide each term then by 4x squared. And you ask yourself, well, what's left? Okay, so 8 divided by 4 is 2, x cubed over x squared is x. Then you keep the minus sign. 28 divided by 4 is 7, the x squareds cancel. It's as easy as that. Now you're going to do the same thing with the next term. What can you pull out between a negative 6 and a 21? Well, your options are either positive 3 or negative 3. Now clearly there's going to be a better choice. Your goal is to get 2x minus 7 when you do this. So if you have a negative 6x and you wanted 2x, would you pull out a positive 3 or divide out a negative 3? Hopefully you're saying divide out a negative 3. And again, watch what happens when I do this. Negative 6 divided by negative 3 is positive 2, and I'll keep the x. 21 divided by negative 3 is negative 7. Look, they match. That was our goal. The two things in these brackets had to be the same. Okay, now we box in one more time. We go up to our plus or minus, and after our plus or minus, and we pull out another GCF. What do I see the exact same in this bracket and this bracket? Well, I can pull out the quantity 2x minus 7. When I take that out, I am then left with 4x squared minus 3. And I'm setting this equal to 0. Okay, now, if you can get that, hopefully the next part's the easy part. Here we're just going to tee it up. Now, some people don't like to show these steps, and that's probably why I didn't get the answer right. Slow down and write each equation out and solve step by step. Okay, so on the left side, I'm going to add 7. So I've got 2x equals 7, divide by 2, x equals 7 halves. There's one nice answer. Okay, on this side, I've got 4x squared. I'm going to add over the 3, so equals 3. My goal is to get that squared by itself, or x squared, so I'm going to divide by 4. So now I've got x squared equals 3/4. And to get rid of a square, I'm going to take the square root. Now, don't forget, in front of every square root goes that plus minus. Was that one thing you were missing, maybe? So you might be thinking you have x equals plus or minus radical 3/4. Now, unfortunately, that's just not simplified. That radical can go further. When you take the square root, you're really just doing it to both the top and the bottom. So it's the square root of 3 divided by the square root of 4. And then I actually know the square root of 4. So I'm going to say it's plus or minus radical 3 over 2. So I have three answers. 7 halves, positive radical 3 over 2, and negative radical 3 over 2. Question 3 was a nice one, find the inverse. So inverse, again, feel free to go back to Moodle. The two things you want to do are switch the x and y, and then of course solve for y. So I'm going to say x equals 2/5 y minus 12. Okay, and my goal again is to get this y by itself. So hopefully you're thinking add over the 12 equals 2/5 y. Okay, now here's the part that some of us forget. You don't want to divide by fractions. That gives us a complex fraction, and then we have to do a ton of simplifying. The easiest way to get rid of a fraction is to multiply by its reciprocal. Okay, so the reciprocal of 2 over 5 is 5 over 2. And the only reason that works is because the 5 on top cancels with the 5 on the bottom, 2 on top cancels with the 2 on the bottom. Now, if I did it to the right side, though, I do have to make sure I do it to the left side, because in math, everything has to get balanced. So now I'll just distribute that. 5 halves x plus 5 halves times 12 equals y. And I'll clean that up one more step. 5 halves x, this is 60 divided by 2, gets me a plus 30 equals y. And there you have it, you have your inverse. Maybe some other things to know about inverses. They are reflections over the line y equals x. But again, feel free to look over your notes on inverses. All right, express in simplest form. This was called rationalizing the denominator. All right, so you'll see I've already taken the liberty to do the first step, and that, of course, is multiplied by the conjugate, which I'm assuming you already started with. Okay, so now it just comes to foiling these out. And I know I have to FOIL because I have two binomials. So my first, remember when we multiply radicals, anything outside the radical gets multiplied, and anything inside gets multiplied. So I'm going to say I get 3 radical 49. Then I'm going to do the outers. That's going to be a positive 15 radical 14. My inners is just plus radical 14. And my last, I'm going to say plus 5 radical 4. Then I'm going to go ahead and do the same thing in the denominator. That's going to get me, let's see, radical 49. And perhaps you simplified while you went through it. That's even smarter. Plus 5 radical 14 minus 5 radical 14. and minus 25 radical 4. Now, some people didn't even multiply these two because they're conjugates. We know those middle terms are going to cancel. And I'm just going to go slowly and clean this up. Radical 49 is 7. In math, when numbers are next to each other, we multiply. You'll notice there's no plus sign. So there's my 21. These are like terms. I have 15 radical 14 plus 1 radical 14 gets me 16 radical 14. Square root of 4 is 2. Again, they're next to each other, so I'm going to multiply, so plus 10. And I'm going to go ahead and clean that numerator up one more step and add my like terms together. 21 and 10 is 31 plus 16 radical 14. And I'll do the same with the denominator. Radical 49 is 7. Radical 4 is 2. Multiply, so minus 50. So my denominator looks like negative 43. And that is where my final answer came from. Now, if you can, you'd want to pull out a GCF on top, but of course I don't have one with that 31 there. All right, lastly in the expansion, the best part is you don't have to memorize this formula. It's on the sheet. It's the first thing we've actually used on the formula sheet. So the one thing I will quickly say is that I'm going to turn this to a plus and make this 1/4 a negative because that's how our binomial expansion is. It wants a positive inside. So I'm just going to pause it and I'm going to go ahead and write out my theorem and see if we get the same thing to match. So typically I would never write them this way. I just couldn't fit them across on the iPad here. So I did write them down, but hopefully those are the 4 terms you have. Now again, NC0 is where we're starting. It does say start with A, which is the first term, to the n power. So I am starting with whatever my n was, the B term with the 0. And these went down, and these went up. I subtracted 1 each time, or added 1. All right. I'm going to simplify, like I said, each term for you. This was 1. Anything to the 0 is 1, so those are completely gone. All I had to do was cube everybody I saw in here. 2 cubed became 8. Power to a power is multiply. That's where 8x to the 9th came from. Now the next step is going to be a little more involved each time. 3c1 is 3. I'm going to use parentheses. I'm going to square everybody, so I get 4x to the 6th. And I'm going to leave everybody to the first power, which means don't touch it. 1/4 y. Now I'm going to multiply. And if this bothered you, it's always easy to turn everybody into a fraction. Fractions are actually very simple because when you multiply, you just go across the top and across the bottom. So on top, I get a negative 12x to the 6th y. And on the bottom, it looks like I just get a 4. And if you can simplify, you want to simplify, that's a negative 3x to the 6th y. My next term, again, that turned into a 3. I'm going to use parentheses, raise everybody to the first, so you leave it alone. And now you have to square everybody. So remember, anytime you raise somebody to an even power, you always get a positive number. So I know that's going to turn into a positive. Square the top, I get 1. Square the bottom, I get 16, and a y squared. Again, fractions are easy. Put them over 1, multiply the top, multiply the bottom. So I get 6x cubed y squared all over 16. Again, I can simplify here. They're both divisible by 2. So I'm going to say that's equal to 8 x cubed y squared. Then I'll go ahead and get that last term. Let's see. This becomes a 1. This becomes a 1. And now I'm going to cube everybody. Odd powers mean they're going to remain negative if they are. So cube the top, I get 1. Cube the bottom, I get 64. Y cubed. Lastly, I'll just write out my terms in order with correct signs. I had 8x to the 9th minus 3x to the 6th y plus 3/8 x cubed y squared. That should have been a negative, minus 1 over 64 y cubed. All right, well that does it. We look forward to some more good practice tomorrow.